So today in Algebra 1, we'll be talking about polynomials and types of polynomials that we have. Basically, giving a formal definition of this stuff as to what is it for and how do we use it? Well, that I guess comes in the future. So to begin with, we're going to go ahead and define what is a monomial, which is the most basic or simplistic type of polynomial there is. So by definition, a monomial is the following. Anything where you have a number, a variable, or a product of a number and a variable. All of this falls into the category of a monomial. So for example, if I have, say, 5x right there, that is going to be considered as a monomial because you'll notice that that is a product of a number and also a variable. The 5 is the number and x is the variable. Another example, maybe if I have say 4 multiplied by a squared times b, that is also considered as a monomial because you have a product of numbers and also variables. You can also have a number all by itself too. So for example, number 12 right there, that is also considered as a monomial by definition. And then if I have say just plain old x or maybe plain old z like this, those are all considered monomials then. Okay, so if it's just a bunch of numbers and variables multiplied by each other, or maybe just number by itself or variable by itself, those are considered monomial. Now to extend upon that, we're now going to define what is the degree of a monomial then. The degree of a monomial is supposed to be the sum of the exponents of its variables. The degree of a constant is supposed to be equal to 0. So going to some of the examples that I have over here, previously over here, this 5 times x, that is what is known as the first degree because you'll notice that you have one single x right here and the exponent in this case is going to be 1. Now, in the second case over here, that is going to be a third degree monomial because we have 3 different variables. We have a squared, which is the same thing as a times a, and then times b. So because there are 3 variables multiplied each other, that's why it's a third degree. For the case of the constant, this is also known as a 0 degree because there are no variables over here multiplied by each other. So that's what this parentheses part means right here. So the degree of a constant is supposed to be 0. Whereas the last two, those are going to be first degree because it's just x by itself and z by itself. Looking at the examples that we have over here below, this right here would then be a third degree then because we have x to the third. For this guy underneath it, that is going to be a fifth degree because we have x to the second times y to the third. So x times y times 5. There are 5 variables total in each multiplying by each other. That's why it's 5 degrees. In that sense, you're basically adding up the exponents over there for the variable parts. For the number underneath it, that is pi. So there is going to be a 0th degree in this case because there are no variables over here. Pi is a constant, it's not a variable, so be careful about that. For the one afterwards, this is not a monomial, so this is going to be not a monomial because what we're doing is we're taking the we're taking the variable a and then dividing it by another variable b. Remember, monomial is a case where you're just strictly multiplying the numbers and or variables to each other. You're not dividing by them or anything like that. The number 3, once again, underneath it, that is going to be a monomial, and this is going to be the 0th degree because there are no variables. And finally, underneath it, the square root of r, that right there is not a monomial either because we have a square root sign, which is not exactly multiplying or dividing strictly by a variable. Okay, keep moving on. So now we're going to discuss what is a polynomial then. Okay, so a polynomial is defined as a monomial or a sum of difference of monomials. So meaning if you have a whole bunch of monomials where you're adding all of them together or subtracting them together, any kind of combination of the two, that will be considered as a polynomial. So for example, in the first one right here, this is going to be considered as a polynomial because notice that you have 2 different monomials, which is 3x squared and then plus 5a. So put them together, that will be a polynomial then. To be a little bit more specific, we call that a binomial because there are 2 of these monomials here. So we can write that here. So binomial. The one underneath it, that is going to be also an example of a polynomial. So this one, there are 3 terms where you're adding together. So that is known as a trinomial. Okay, because there are 3 of these monomials added together. The one underneath it, that is also a monomial. This right here is a binomial because you have two terms. Remember that 4 is still considered as a monomial because it's just of 0th degree then, okay? So this is also going to be a binomial. But whereas on the right-hand side, because of this nature of 5 times x to the third divided by y to the 7th, because you're dividing by a variable, that is not considered as a polynomial. So this right here, not a polynomial because we're dividing by 7. Divide by this y to the 7th power. The one underneath that, that is a polynomial, even though if you're looking at the 1/4 part and you're wondering, oh, we're actually dividing by 4. Well, we're not dividing by a variable, so that's why it's actually okay. So this is going to be considered as a trinomial because we have 3 terms total where we're adding and subtracting these variables, or 3 of these monomial terms. And finally, for the last one, this is considered as a polynomial as well. And this is going to be, again, 0 degree, and this is going to be a monomial, okay, all by itself. Okay, so for each of these polynomial, you'll notice that there's something that we can refer to, which is going to be the degrees, which tells us, how big these polynomials are. What we're doing is we're just combining the definition of degree along with the definition of polynomial to find out what is the degree of each polynomial. So here, for the next part, the degree of any polynomial is supposed to be the greatest degree of each of the term of the monomial. So here are some examples. In this first case over here, that is going to be a monomial. And to be a little bit more specific, we're going to say of 5th degree, because you'll notice that degree is going to be 5 since there are 5 a's all multiplied by each other. The second one, where we have a binomial, where we have 2 terms added together. This one is supposed to be of 4th degree. And the reason for that is if you look at each part individually, you have a monomial over here, which is made up of a squared. You have a monomial over here, which is made up of b squared times xy. Whichever one has the higher higher degree, that's the one that we're going to take. Since you're comparing to a 2nd degree for a squared and b squared times xy, that is a 4th degree, we're going to take the higher number, which is going to be the 4th degree. Then we look at the next one right here, which is a trinomial. And for each part, we're going to look at the variables once again. For this first portion, that is going to be a 3rd degree because we have 3 different variables multiplied by each other. The second part, that is going to be a 2nd degree. And then the last part, that is going to be a 1st degree. So again, by our definition, we're going to take the greatest degree. So this is going to be considered a 3rd degree trinomial then, okay? Anything that is greater than a 3rd degree, anything that is greater than a 3 terms polynomial, we just go ahead and call it 3 terms. We don't even bother with quadnomial or syncnomial or whatever. We'll just go ahead and call it polynomial then, okay? Okay, so now I want to take each of the following polynomial, and I want to determine, well, first of all, I want to determine if each of the expression is a polynomial first, and then from there classify what is the degree and rewrite it in descending order. Okay, so taking a look at the first one over here, we have 4 times x to the third plus 6x plus, minus 2x squared and then plus x squared. So you definitely can see that all the terms are strictly multiplied and adding and subtracting. There's no dividing of any kind of variable. So that definitely means that it is a polynomial. Now, something that you might not notice is that the last 2 terms over here, they are actually kind of the same because, well, they're kind of like negative 2x squared and then plus x squared. So that's like saying minus 2 apples plus an apple. You can combine those 2 terms together. To be a little bit more specific, all of these right here, these 2 terms, we can combine that into negative x squared instead. So finally, if we put them all together, I'm going to go ahead and put them in descending order. So that's going to be 4x to the third, because that has the highest exponent, minus x squared, and then plus 6x, just writing them in descending order. So this is what is known as a trinomial, because there are 3 of these monomial. And this is going to be of 3rd degree because we have x to the third as our highest exponents in this case. Okay, moving on to the next one over here, the next to it. You'll notice this time we have 3 times ab squared minus 5c squared d plus 7 minus ab squared and then plus 8c squared d. So first what I'll do is just the same thing as before. I'm going to see if there are any like terms that I combine. And there are definitely some, because if you look at this first part right here, 3ab squared, and then we also have negative ab squared. Those two can combine together. Again, it's like saying you have 3 apples and then minus 1 apple. So the total together, that will give you 2 of the apples. So that gives you 2ab squared, because they both have ab squared in common. Then similarly, I'm going to go ahead and combine these guys right here, the negative 5c squared d, and then we have the 8c squared d. They both have c squared d in common, which I can kind of combine together. So it's like saying 8 bananas minus 5 banana, and that will give me plus 3 bananas, so 3c squared d, then that's the next part. And then we also have the 7 all by itself, so I'm just going to go ahead and plus the 7. Now what I want to do is put them in order. So I want to make sure that it's in descending order. The first part I have 3 degrees, and then the second part I have 3 degrees. So it looks like we're okay if we just kind of leave it as is. We don't have to kind of rearrange it in any particular way. Finally, I think that's pretty much it. So we're going to go ahead and categorize it. Yes, this is a polynomial. And just like before, this is a trinomial because we have 3 terms adding up together. And then in terms of degrees, that's also going to be 3rd degree then. Okay, so just by dumb luck, we get this kind of same answer. For the last one over here, this one, it is not a polynomial, so we don't even have to categorize it. Mainly because if you look at the exponent, it's x to the power of 5.1, which is not a whole number. So anytime that happens, then we just go ahead and say we're done. So remember, we have to strictly multiply, add and subtract these variables and numbers only. We can't actually have exponents that are something else that's not a whole number. All right. Well, that should do it. Thank you so much for watching. I will see you guys next time. Goodbye.